Welcome everyone to the 2021 IUG conference. My name is Harpal Gill, and I'm the VP of the CONNX Product Management.
And I'm Bill Luton, Director of R&D.
Today we're going to spend some time with you talking about Adabas data integration with the cloud. Your data needs are unique and you need options. The CONNX Data Integration Suite gives you a variety of different options. Everything from real-time data access. We have something called the CONNX Database Adapter that gives you SQL access to over 150 different data sources on a variety of platforms. And we offer standard connectivity mechanisms with that, ODBC, JDBC, .NET, and OLADB, whether you're accessing an application, cloud, or mobile app. We also can extend that same database adapter for real-time data visualization. So perhaps you have a BI tool like Power BI, Tableau, Excel, Looker. We can go ahead and give you access to over 150 different data sources. We'll go a step further and give you something called data virtualization. If you have multiple database adapters, you can connect to multiple data sources and have a single view, a virtual view, if you will. Imagine if you have Adabas on the mainframe, you have vSAM on the mainframe, and maybe something on-premise and a columnar database in the cloud. We can go ahead and virtualize those into a single view so you can write queries against it or perhaps drive a real-time dashboard. And finally, we're going to take a look at data movement with our CONNX Data Sync solution. In fact, that will be the bulk of the demo, and we'll show you how we can move data from any of the 150 supported data sources to any of the 150 supported databases. In this demo, we'll actually look at movement from Adabas, vSAM, to the cloud, to a data lake in the cloud, and then we'll actually look at movement back from the cloud, again, application perhaps sitting in the cloud, back to Adabas. So at this point, Bill, why don't you show us our data movement solution?
Sure, but before I do that, Harpal, I want to start by showing the CONNX Data Dictionary. Because the CONNX Data Dictionary is actually at the center of everything that we do with CONNX. And what the Data Dictionary does is it's a repository for the metadata that defines the data that we want to access. Not only does it define the data we want to access, but it also has all the information we need to connect to each of the back-end databases that you've mentioned.
So how do I get my data into the CONNX Data Dictionary?
Well, I've got an example of a CONNX Data Dictionary up right now, and I have several different databases in here. And the answer to your question is it depends on the database, but I'm going to kind of talk about a few at a high level and how those work. So if we look at the simplest way to do an import, it would be to an actual RDBMS. For example, Azure DB or Microsoft SQL Server, for example. In order to import the data from those database types, all CONNX has to do is go out, connect to the database, and then it queries from the database the metadata. Brings that data in, presents it to the user, you decide what you're interested in, and then we go back to the database and ask for the metadata for the individual tables that you want, and we store them in the CDD.
So is vSAM going to be the same as that RDBMS?
No, vSAM is at the other end of the spectrum. So vSAM, as you know, is just a flat file, effectively. And we don't have a DBMS to talk to get any information about it. So the way we bring in vSAM information is we actually import your COBOL copybooks. So we would prompt the user to tell us where the copybook is. We'll bring the copybook in. We'll analyze that copybook, figure out what the name of the table is, for example, as well as what the columns are that you're interested in, the data types, as well as offsets and lengths, and we'll store all that so we know how to access the fields in the vSAM file. But there's still a piece missing, because with a copybook, we don't have any information about the actual file. So in that case, the user has to actually tell us what the name and location of the file is as well. From there, we can go out, we can validate that the file is actually there, if it's an index file, we can read the index information and bring all that back into the CDD. And from there, we now have a picture of your file that we can use when we're accessing this data through a SQL command.
So where does database fall? Is it like the VSAM or is it like the relational?
Well, Adabase is actually in the middle. So Adabase is an actual database system that we have the ability to call into Adabase and get metadata information. But what we get from the Adabase is the FDTs. And within the FDTs, we have just the typical Adabase short names. We don't have those long names. For example, many of our customers use Natural, and they're used to putting their metadata into Natural, and they have those long names. So when we import from Adabase, we can do a simple FDT import if we want. And then that will just bring in just the short names, along with, for each field, we do get the data type information and offset information and all of that. But we can also bring in natural sysobgh files. So if you do that, then we can overlay your natural definitions over that FDT and combine them together, and that way you can also see the long names that you define in natural. We also support a method called dynamic DDL imports, and a dynamic DDL is a script that looks very much like a series of create table statements. And as you know, in a create table statement, we actually define the columns and the data types, and CONNX will read those and then overlay that over an existing FDT, and between that combination will give us a picture of what it is that we're after.
So once we've built this data dictionary, now we can go in and do our data integration.
Correct. But there's one more aspect of Adabase that I didn't mention that I need to, and that is, as you're aware, Adabase actually uses MUs and PEs very heavily, as well as MUs within PEs. And so I have an example here that we're going to be using in our demos where I'm using the standard Adabase sample file called employees. And each one of these files or tables within my CDD is actually an element of the employees table. And if I look up here at Adabase file name, for example, employees is 1_11. Right. This indicates database ID of 1, file 11. And you notice for each one of these, they're all the same. That's because these tables down here with the underscore in them, these are all MUs, PEs, or in the case of the bonus table, an MU within a PE. And the way CONNX makes this Adabase record look like a relational table or a set of relational tables is we actually break the MUs and PEs out into what we call rotated tables. So from a relational perspective, from SQL's perspective, these are separate tables, and that's why they're listed individually here, even though under the covers, CONNX is going to combine them all back into that one record. From a relational perspective, they're going to look like separate tables where they're joined on the ISN.
That's great, Bill. So now let's take a look at data sync and show the audience how we do data movement from these data sources to a variety of data sources.
Absolutely. So this is the data sync client that I brought up. This is a new client with version 14.5 that we've just released, and it's data sync is now a web-based application consisting of a web client that is connecting to a REST server running up on a Windows server box. So the first thing that we need to do with data sync now is we actually have to log in. So I provided my credentials, and I'm going to log in. And we've now been brought to our main overview screen for data sync. And what this screen is divided into two portions. The top half would show us any current activity that's happening right now. The bottom half would show historical information about syncs that have already been run. Now, normally in a production environment, data sync is a tool that you would schedule your synchronizations to run, and you might have them running constantly all day. You can schedule syncs to run as often as once a minute and as infrequently as once a year. It's just up to what your business needs are. For the purposes of our demonstration, I'm not going to actually be doing any scheduled syncs today. I'm going to be running everything in a real-time mode, but when I run them, we'll be able to come back to this screen and see the actual activity as it's happening.
That's great. Can you walk us through some of the tabs?
Absolutely. So the first tab is the Tables tab. Now, Data Sync does two types of synchronizations. We have extract and load, or EL, where we're simply extracting all the data from a table and loading it into a table that looks exactly the same in a target somewhere. Now, it can be on a different database, but it's going to have the same columns that the source has. We also have ETL, which is extract transform load. That's a little bit more complex of a data movement, where we can do things like change data types or change the number of columns, change column names, do things like that we'll get into in just a moment. But the first thing I want to talk about is the extract load. And so from there, we get to that from our Tables tab. So I have a few tables that I'm going to synchronize for us. I have an employees table that's in Adabas. I also have a couple of larger tables that are actually in an on-premise SQL server. I'm currently set up that my default target is configured right now to be Snowflake. So all the table data syncs that we're going to be doing are going to be from an on-premise database up into my Snowflake target.
So Adabas is a non-relational database, and Snowflake is a big data database. How do you deal with a format change?
Actually, CONNX handles all of that. It's handled completely transparently. The CDD that we looked at is actually the key in how we do that. So when I was talking about when we bring the data in from the databases and store it in the data dictionary, one of the pieces of information that we store, in the case of Adabas, for example, is the actual native data type. CONNX will then take care of, when it reads the data out of Adabas, it will actually convert the data from that native data type that was identified in the CDD, and while it's in flight, it will be converted into a SQL data type. Then when it gets to the target, in this case Snowflake, we have already also imported the Snowflake database, and we're then able to convert from the SQL type into Snowflake's native data type. And all of that is handled completely transparently, seamlessly under the covers, and the user doesn't have to even be aware that it's happening.
Wow.
So let's go ahead and move some data.
Yeah, please.
So I'm going to select 3 files. I've got that sample employees file that's in my on-premise database, as well as a couple of larger files that I'm going to move. Now, whenever we do a sync, we're going to pretend this is the very first time it's ever been done. The first thing we have to do is what we call a full reload. And what a full reload does is it moves all the data from the source to the target, so that the source and target are completely in sync before we do any change data capture. Now, if the target table doesn't already exist, this tool will create it for you, and it'll create it based on the metadata from the source. If it does already exist, then you can either truncate the data in the target and reload, or you can drop and recreate the table and then have it load. The tool will use, if the target database supports bulk loads, the tool will use bulk load technology, so doing full loads is actually very fast.
Excellent.
So let's go ahead and do a full load from those 3 tables. So here we see that the employees table is getting ready to go, along with my other 2 larger tables. Now that they're pulling data, we have a little speedometer here that's showing us our data movement. I can also look at my current syncs. This is the last one that's just finishing up. I can choose to stop the process if I want while it's in flight, but of course we're going to wait till it finishes. If I come back to my summary screen, now we'll see that here are those 3 tables that we just ran. I have my employees table that I brought up from Adabas, along with my other 2 larger tables that we pushed up into Snowflake.
So that was a full load. Can we change some data in Adabas and show what we call incremental or change data capture?
Absolutely. So I'm going to bring up a ad hoc query tool that ships with CONNX. It's called Infonut. And I'm going to connect to that same CDD that we're using in DataSync. And this is going to allow us to access those tables in real time through the Infonut tool. So the first thing that we're going to do is I'm going to do a select star from the employees table in Adabas, and I'm going to execute this query. And here we have our data. And as you see, I changed the very first record to be you.
Thank you.
And let's go ahead and just change this zip code to 98999. I don't even know if that's a valid zip code, but that's
Perfect.
okay.
Sounds great.
We're going to update it. And now what we're going to do is we're going to come back and we're going to run, let's just do all three of them again. We're going to run synchronizations on these. Only now instead of doing a full reload where we're actually moving all the data, I'm going to do an automatic. And what automatic's going to do is cause DataSync to go out and actually analyze each of these tables and figure out if anything changed or not. If it detects a change, then it will only move that change. If it doesn't detect any changes, it won't move anything. And that's why I've selected those bottom two as well, because I didn't actually change anything.
Right.
So now we're going to click OK. Now, by the way, if something changed, then that type of synchronization is going to be called an incremental update. And so because we're making incremental changes to the target. And those actually finished up pretty quick, and we'll see now that for our employees table, it actually detected one update, and it moved that one update to my target. And then you see for the other two, it didn't detect anything. You also notice those other two went by very quickly because there had actually been no changes made to them.
So this was a data movement from Adabas to the cloud. What if we have multiple sources? How would you do something like that? Perhaps I have Adabas in my Linux world, and I have something on the mainframe, maybe vSAM, I think I saw in our data dictionary. How would you combine those to the cloud?
So in order to do multiple sources like that, that's where we get into ETL, or transformations. So as I said earlier, typical types of transformations are usually things like you're changing data types or you're adding columns to your target that don't exist in the source. A good example of that would be you would drop a timestamp column in so that whenever you update or insert a record on the source, you'll actually get a timestamp telling you when that happened. You might also want to filter columns. But to me, the most interesting type of transformation is actually introducing a concept that we call data virtualization as a source. So not only can we virtualize data with CONNX, in real time, where we can look at data or reports that are based on multiple tables and bring them all in and make them look like one table in real time, we can actually take that virtualized concept and use it in data movement. So I can take multiple tables from different databases or different platforms, bring them together as a single virtual source, and then do my change data capture against that virtualized source. And so I'd like to show you that.
Yeah, please.
A transformation called order report. And if we come in and look at this transformation, instead of being based off of a single table, it's actually based off of a query. And this query is doing a join between the customers table in vSAM and the products and orders tables in Adabas. So I'm going to join across three different tables that are sitting on two different platforms and two different database types. So single vSAM that's in an on-premise mainframe, and two Adabas tables that are in an on-premise Linux. I'm going to use those as a source, and I'm going to move those up to an Azure DB.
Excellent.
Okay? So let's go ahead and select this transform. And just like before, I'm going to start with doing a full reload. So I synchronize, get my source and my target completely synchronized. I didn't do my large table this time.
So that was pretty quick.
So that was pretty quick.
So can we change data just like we did in the other one? Can we show change data capture here?
We absolutely can. So before we do that, let's take a look at what that order report looks like. So I've created this order report. This is up in my Azure DB now. And this is the data that I just moved out there. And what we're going to do is actually go in, and we see that we have this customer name here, this Mary Grape Wine Merchants. And you'll notice that there's 7 records for it. And the reason for that is for this one customer, we actually have 3 distinct orders. We have order ID 1, 15, and 70. And then for those 3 orders, we actually have 7 products. Because what we've done is we've joined together the customers table, the orders table, and then for each order we have the description of the products that they ordered.
Excellent.
So we're going to go in and we're going to change one record in the customers table. And I'm going to show you how that gets picked up across the board. So we're going to go to our VSAM customers, and I'm going to query this, and we're just going to scroll down to our Mary Grape Wine merchants here. And it shows them as being in West Vancouver, and they're actually in East Vancouver, yes. So I'm going to make this change. Now, as you recall, that one customer,
that's 7 records.
exactly, had 7 records. So we actually need to update 7 records in our target database, not just 1.
Right.
So what the tool is going to do is it's going to go out now and it's going to analyze all 3 of those tables, and it's going to figure out where the changes were, and it's going to pick up the changes and move all the affected records. So in our case, we changed 1 record in 1 table, but it's actually going to affect 7 in the target.
So we should see 7
So we
changes.
should see 7. So again, we're going to do an automatic. It's going to go out and analyze all 3 tables. It's going to pick up the record that changed, and you'll see
7
it figured out that there were 7 updates. And then let's just go back real quick and take a look at those. Oops. And go to my order report. And now if we scroll down, we will see that indeed we've all moved all the records to East Vancouver. And so this is an example of actually using data virtualization as a source when we're doing data movement.
So we had 3 tables, 2 from Adabas, 1 from VSAM, virtualized together, move data to the cloud. Can you tell us what the difference is between transformations and groups? Because that sounded like we were grouping data there, didn't it?
Yeah, so with groups, what we were doing earlier in terms of virtualization, while yes, that seems like we're grouping data, what we mean by groups is actually the ability to group transformations or tables or combination of both together, primarily to make it easier to run scheduled syncs. So if I come over here to groups, for example, I have this group called Big Files. And if we take a look at it, I've just put 4 of those larger files in here. So let's say that I had a set of tables that were related in some way. You know, maybe they were all about my month-end reports or something, and I wanted them to all run once a month. Well, instead of scheduling each one of those syncs separately, I would put all of those into a group called month-end report, and then I would schedule just that one group to run. And then when that one group is triggered, it will do all of them. Nice. Now, I'm not going to do it via schedule, because again, we don't want to wait for it to fire.
Sure.
But I will go ahead and run it manually so that you can see what I'm talking about. So the first thing, again, we're pretending it's the very first time. And when I do these full syncs, you just do these one time. And then from then on, you're always doing automatics. But when I run the full sync, we're going to see now that all my tables in the group are now syncing. And we'll see then we have an indication of what's going on. We can see how many are active, how many are finished. And then as they finish up, of course, then they'll move down into the historical tab. And as soon as this last one's done, there We'll refresh, and now we see each of our larger files ran, and as well as our group. So the group shows the roll-up of everything. So the group itself moved 810,000 records to Snowflake.
Wow.
And it did it in 27 seconds.
Wow.
And then up here we have the individual stats for each one of the syncs. Now, because they were running in parallel, overall it took 27 seconds, and then this just gives us the individuals for each one.
That's great. So Bill, we've been moving a lot of data and changing data, going from on-premise to our data lake in the cloud.
Mm-hmm.
A lot of applications people are adding new applications to their environment. They have their system of record, perhaps an database system in Linux, but now they're adding a module up in the cloud, an application that's perhaps in SQL Azure. Mm-hmm. Can I move data? Can we show how we go from SQL Azure back database? Because if my system of record is here and I'm adding, maybe I've got a new HR module up there that I want to move some of the added data over. How do we do that?
Yeah. So in that scenario, let's pretend that we have an HR app running in Azure, and it's storing its data in Azure DB. And let's say that, remember earlier we were talking about the employees and the income and bonus tables.
Right.
Well, let's pretend that the bonus table is actually updated by the HR app that's up in Azure.
Okay.
But my payroll is running against Adabas. So I need to move that data from Azure, once HR is done updating everything, down to Adabas on premise so that my payroll system can pick that up.
Perfect. We want to get paid our bonus.
We do want to get paid our bonus. So the first thing that we're going to do is let's first take a look at the bonus tables. Actually, let's first do a full sync.
Okay.
Now,
we always start with a full sync to make sure.
We always start with a full sync, yeah. Now, again, this full sync could have happened 3 years ago. We're just
the first time
in our pretend world here. We're going to do a full sync, and so I'm going to move my employees bonus from Azure down to Adabas. Now, I do admit that that was just a little bit of smoke and mirrors, so let's go ahead and take a look at what actually did we do. So I have a transformation that I've called employee bonus. My source table is up in Azure, and it's a table called employees bonus. For my target, what I've done is normally, like I said earlier, the default target that I have set up right now is to go to Snowflake. But in a transformation, I can actually overwrite that. So I've told it I want this to go down to Adabas to a table called bonus.
Nice.
And then from there, we run it, and it moves the data down. And I've done my full sync now. So let's go look at my bonus table that's up in Azure. And you remember you were ISN number 1.
Correct.
And, well, the problem, Harpal, is somebody set your bonus to be $30,000.
That's a little out of whack with the other ones, isn't it?
Yeah.
I don't have a problem with that personally. I actually would love to get that, but I think someone might catch that and stop that.
I would love to give you that bonus, but I'm afraid HR said no. I submitted it. I was actually, I submitted it, and
Thank you.
HR came back, and they were laughing hard, and they said no. But I was able to get you 5,000.
Oh, well, I'm still well above the rest, so I can't complain. I appreciate that.
So sorry about that, but your bonus has been lowered, and so now in our hypothetical, we're going to have pretend that the HR people, they've updated everything, and what we need to do now is synchronize the changes that are in the Azure DB bonus table with the data that's in Adabas so that so that payroll can pick that up.
Excellent.
And so what we're going to do is we're going to do an automatic sync again, and it's going to figure out that it needs to do an incremental. It's actually a very small table, so it moved very fast. We didn't even see it show up.
We see the one change.
It did figure out that there was one change, and it moved that change down to the database of record that was in my on-premise database, where payroll can now pick it up and pay you your bonus in the next pay cycle.
Excellent. I see there's a tab we didn't look at, the Schedules tab.
Yes. So I've been alluding to schedules throughout the presentation. Typically in a production environment, you would make heavy use of your Schedules tab. And what the Schedules tab does for you is it allows you to set up schedules with our built-in scheduler. Now, you can also use your own scheduler. One of the cool things about the DataSync server is it's actually a REST server. And so you can call into that server, make exactly the same calls that the web-based client makes. You can do everything on your own that we do here. So you can actually set up your own scripts to do anything you want and actually run those scripts from your own scheduler. But we do supply a scheduler that you can set up, and here's just a simple schedule that I have created that will schedule the Adabas employees table. And I select the table that I want, and then I just tell it the schedule that I want. So for this example, I said run daily every 24 hours, which means run once a day. And then I also set up a start and end date. So as you can see, this is only going to run one time. But normally you would want to set this up to run on a little bit more meaningful of a schedule. Now, in addition to the tables that we can set up, in addition to setting the schedule, we can also set the sync type that we want. So for example, you might want it to always do a full reload. I don't know why you would, but you might. Normally you would just set it to always do an automatic. You can also set it to only run when the schedule fires, but also a trigger file is available. So you might want it to, have the schedule set to run every 5 minutes, but maybe you only want it to the synchronization to run if some other job is finished. So you'd set that other job up to drop a trigger file when it finishes, and then when the schedule fires, it would check for that trigger file, the existence first. If that file's there, then it would go ahead and run. The last tab is our sync tasks. From here, we can schedule before sync tasks, on success tasks, and on failure tasks. And all a task is like in Windows, a command file or a batch file. So for example, if every time before a sync runs, I need to run some batch file, I would simply give it the path, and I'll call it sometask.bat, right? And then I could have a success. So if it succeeded, it's going to run some other task that might do some post-processing, or perhaps on failure, it might do some post-processing to deal with a failure.
Probably call someone late at night.
Well, that might be, and in fact, if I could just show you one other feature that we have. So actually, earlier I talked about the default target was Snowflake. It's actually set here in our settings. But I did want to show you one interesting feature that we have that could call somebody in the middle of the night, or at least email somebody in the middle of the night. We have this SMT mail feature where you can actually set up to have DataSync send you an email. You can have it anytime a synchronization starts. It can send you an email. It can send you an email on success. That could generate a lot of email.
Right.
It can also send you an email on error. So if an error occurs, you'll actually get an email from the system telling you that an error occurred. And so if you're a DBA, you know that you need to go in and take a look at what happened.
And that's probably what it would be more meaningful for me to have.
Correct, yes. Yeah.
Well, that's great. So we got to see all of the data integration. We saw a movement from on-premise to the cloud and back from the cloud to on-premise. I think that concludes this part of the demo. The CONNX data integration piece you saw. You can feel free to go out to softwareag.com/CONNX. You'll find some PDFs or brochures. You'll actually find a Bloor report. So Bloor Research has done a review of what they call the pure play data integration tools, and Software AG's CONNX was rated a champion in that space. We have an ebook out there. You can also request a demo. It's really been our pleasure. Thank you for your time.
Thank you very much.